Okay, so as usual, please make sure that you have your learning targets in front of you, and you also should have the note handouts that go with this section. That can be found under the link in my website, right underneath the link for this video. So today we're going to talk about membrane structure and function. You did today in class on Friday, you did a POGL activity that was a very good introduction, and so most of this, some of this should be a review. To start, we've got, and this I know you had on your POGL, okay, make sure that you have located, give me just a second to switch to pen mode. Okay, make sure you've located the polar hydrophilic head. Right there, that's this part here. Okay, the non-polar hydrophobic tails, that's this fatty acid chains right in there. Okay, and we're going to talk about a phospholipid bilayer because there's 2 layers of phospholipids. Okay, so learning target that you should be addressing today is describe the structure of a cell membrane using the fluid mosaic model. So what is the fluid mosaic model? Well, if you break it down, fluid, okay, it means we're talking about this whole membrane. It has this fluid consistency, or in other words, the molecules kind of float. It's not some static, or it's not some, structure that's glued down in cement or anything. It's a very fluid consistency, which means it can move, it can bend, it can do what it needs to do. Alright, mosaic, we're talking about these proteins, they quote-unquote float in a bilayer. So there's that 1 layer, there's 2 layers. Bi means 2. Okay, we need to talk about, we've got some peripheral and integral. So what do those mean? Well, peripheral means this is something that floats, quote unquote, on the inside of the surface of a membrane. So if you take a look down here, here's a peripheral protein. Okay, so anything that's floating on the inside is going to be peripheral. Integral is going to be anything that penetrates the whole membrane. In other words, it's exposed on both sides. So that right there is going to be an integral protein because it is on the top here, it's on the bottom here, which allows for passage through. Okay, and we'll talk more about these in more depth as we go. So plasma membrane, it consists of more than just a phospholipid bilayer. It contains cholesterol, carbohydrates, and proteins, all of which are sandwiched in the phospholipid bilayer. So let's start with phospholipid bilayer. Phospholipid bilayer, its heads are polar, tails are nonpolar. If you remember what polar means, okay, polar means you've got a positive and a negative charge. Okay, just like you have a north and a south pole on Earth, we've got a positive and this negative charge. Okay, that becomes very important because the polar, the polar heads are going to love water because the positive charges on the polar heads are going to be attracted to the negative charges in the water. And then the hydrophobic, they are hydrophobic because they are nonpolar. So they don't have a charge, they don't want anything to be, they don't want any water to be near it. So what happens is that these hydrophilic heads, they're like pushing each other, crowding around to get to the water. Okay, they really want to be touching the water. The tails, the tails do not. They are going to try to stay away from water as often as possible, which is why you see here, no water. Okay, that's because these phospholipids will form this impenetrable barrier, impermeable barrier that does not allow water or other things to pass through it. Okay, now, very important that you know that double bonds in unsaturated fatty acid tails produce kinks. Okay, so if you've got in fact, I'm not going to draw it. Just look at your POGL, okay, and it does a really good job on that very first page, Model 1. You see a double bond between two carbons that cause that fatty acid tail to turn out almost at a 90-degree angle. Okay, that's important because since it does that, the phospholipid tails, okay, these phospholipids cannot get close enough to form a solid. If you think of your states of matter, solids, the molecules are really packed nice and tight and close. Liquids, they're a little further apart, which gives them this ability to be fluid and to move and to change shapes. And then gases are just, molecules are really far apart. So because of these kinks, because of those kinks, those phospholipids are far enough apart that they can remain fluid. Okay? Cholesterol, this is another part of the plasma membrane that we will find. Cholesterol is important because it regulates strength and that fluidity of the membrane. The cholesterol, if you remember, cholesterol was a steroid, which was another type of lipid. Okay, and steroids were the only ones that had rings. So if you see, anytime you see this ring-like shape, those are going to be a steroid. Okay, cholesterol is a steroid, and it's important because it kind of helps to keep the phospholipids all together. It stabilizes the membrane at warm temperatures, and it keeps fluid at low temps. So warm and low temps, it helps keep the membrane stable, yet still fluid. Okay, good. Carbohydrates. Carbohydrates, there are glycolipids and glycoproteins. Glycolipids are attached to lipids. So if you look in the picture here, a glycolipid would be this green thing attached to a lipid. Okay, here's another glycolipid. Glycoprotein then is going to be attached to a protein. Okay, so, where's a glycoprotein? Right here. It's that little tail attached onto a protein. Here's another glycoprotein. Okay? Next, proteins. Proteins are so important. There are 6 separate functions that they do in a membrane. First, they maintain shape, which we talked about with like the cholesterol, and coordinate changes. They can be receptors for chemical messengers. This is where your proteins and glycolipids are going to be important. They are enzymes, which we will get into when we talk about transport. Cell-to-cell recognition, once again, glycolipids, glycoproteins. Intercellular, or glycoproteins, sorry, not glycolipids, just glycoproteins. They are important in intercellular junctions and in transport. Okay, so that's all we have for membrane. Do your learning check, which is on that handout. You need to label that membrane the best that you can with things like glycoprotein, glycolipid, phospholipid bilayer. Tell me your polar and your nonpolar. Okay, all of that is going to get you to that. Describe the structure of a cell membrane using the fluid mosaic model. Okay, that's it. Have a good weekend.